Hello class, today we're taking a look at a pretty simple topic, which is calculating the square root of a perfect square fraction. So what we want to do today is apply the knowledge that we have from grade 8 with regards to perfect squares and square roots, and see how that might apply when we start looking at a fraction instead of just a whole number. So we're going to do a bit of an investigation, we'll figure some stuff out, we'll put it in our interactive notebook, and you'll have the rest of class for practice. Okay. So starting with this, we want to start with what we know. So we know how to deal with something like 3 squared. We know that squared means multiply two identical factors. So this is going to become 3 times 3, which of course gives us the standard form of 9. And if we remind ourselves of our area model, then our equal factors here are our side lengths. And of course, a square has equal sides. And then the perfect square, the result of that is your area of the square. And so, of course, we could draw this by going 1, 2, 3 boxes across, 1, 2, 3 boxes down. If we fill in all of our boxes beautifully, we have a total area of 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes. And obviously, we have our side lengths of 3 units. And 3 units, so no big deal. Okay, we know therefore our 9 is a perfect square with side lengths of 3. Now that also tells me that the square root of 9 is equal to the square root of 3 times 3, which is equal to the square root of 3 squared. And knowing that our squared and square root cancel out, it of course just equals 3. And again, this is our side length. And the value under our square root, our radicand to be proper, is our perfect square. And that's our area. So then the question is, well, how can we apply this knowledge to something like 3/4 all squared? Well, we know that squared means multiplied by itself, so this is going to be 3/4 times 3/4. And our rule for multiplying fractions is to multiply the top by the top and the bottom by the bottom. When we do that, 3 times 3 is 9, and 4 times 4 is 16. And hopefully you notice that this 9 and this 16 here are themselves perfect squares. 9 is a perfect square, and 16 is a perfect square. And what we've really done there is we've found the area of a square whose sides are 3 out of 4 parts of one whole. You might remember from grade 8 that if we want to multiply those fractions, we can use this same area model, and we can say that we have 3 out of every 4 parts. So, shading down these 3 columns, for example. So 3 out of every 4 parts in our columns. And then our second 3 out of 4 would be 3 out of every 4 rows. And obviously our columns were 3 out of 4 as well. And of course we said, well, we want to have both those things, so our overlap is here. And of course, when we find the area of a square whose area is 9 pieces out of 16 total pieces, okay, our side lengths are 3 out of 4 and 3 out of 4. So we kind of have this picture here, where our total area is 9 out of 16 altogether, and its side lengths are 3 out of 4 and 3 out of 4. So based on that, if we want to take our square root of 16, we know that a square root should be the side length of this square. And we know that that's going to be just 3/4 here. We could also go back to our multiplication here and say, well, since we know that 3/4 squared is 9/16, the square root of 9/16 is the square root of 3/4 squared. We know our squared and square root will cancel, and that gives us just our 3/4. So two different ways of proving that our square root of 9/16 is just in fact 3/4. Now what does that mean for calculating the square root? Well, if we think about this more generally, and we don't want to have to draw out or multiply or anything, what do I do to my 9 to get 3? Well, I know that the square root of 9 is what's going to give me 3. And what do I do to my 16 to make 4? Well, I know that the square root of 16 is 4. And so I can see that when I am taking the square root of 9/16, all I need to do is take the square root of the top and divide it by the square root of the bottom. So that's all there is as far as calculating your basic square roots of fractions. If your fraction is made out of perfect squares, take the square root of the top, divide it by the square root of the bottom. Your fraction answer will be the square root of your perfect square fraction. Now that might raise a question about, well, what if we don't necessarily have perfect squares in our fractions, right? So if we take a look at something like this, we know that we want to determine the square root of 100/25. Now, just from a basic standpoint, I've chosen this fraction because we know that 100 divided by 25 is just 4, and we know that the square root of 4 is just 2. Okay, 100 divided by 25 gives you 4. Square root of 4 is just 2. Now, what if this fraction was a larger equivalent version? So imagine that I multiplied these by 2, and then we had 200/50. Now, top multiplied by 2, bottom multiplied by 2. My question is, does that still have the same answer? And of course, 200 divided by 50 is in fact 4, which gets us to the same place. So when we see a fraction that is not in simplest form, it might be that there is a simpler form that does in fact have your perfect squares. And if we simplify it by, for example, dividing by 2 to get up to that 100/25, we could, of course, come up with our correct answer once we see those perfect squares. 200 isn't a perfect square, but 100 is. 25 isn't a perfect square, but 50 is. Okay? So even if your fraction doesn't look like it's perfect squares, it probably is, and it just is not in simplest form. So what I want you to do is break out your interactive notebook. It should be looking like this at this stage. And I want you to go ahead and fill in this title here on that second layer of sticky notes. We already wrote on the top layer for our basic square roots last day. So I want you to fill in just that second layer of sticky notes title. And once we filled in that second layer, we're going to open up that second layer, and we're just going to write on the upper portion of that second layer today. And this is the information that I'd like you to put in that space. Once you have that information written down on your interactive notebook, I want you to apply it and apply what you've seen here today with your area models and the like to your practice handout. And work on that practice handout for the remainder of today's class. Okay, if we have questions about it or we're not sure about anything, I'll be happy to go back over it once I'm back tomorrow. So that is the plan for the rest of the day. Okay, work on that perfect squares fractions handout. Hope that helps.